While strings have some great built-in functionality, we can convert them to uppercase, to lowercase. We can slice pieces out. We can find out if a word exists in the string. Well, sometimes we need a different approach, and what we're more interested in is the format of the string. And what I mean by that is maybe I want to ask, is it an email address? Not a particular email address, but does it match the pattern for one? Or is it a URL? Perhaps I want to ask if a password has a mixture of uppercase and lowercase letters and special symbols, or verify that a credit card number has the correct amount of digits. Now, to do this kind of work, many programming languages, including JavaScript, have something called regular expressions built into the language. Regular expressions are strange-looking sequences of characters that describe and can match patterns in strings. And nobody finds regular expressions pleasant to begin with, but they're really useful and you should know what they are and what they can do. And there's always two parts to working with regular expressions. First, you create the expression that describes the pattern that you're looking for. And next, you try and apply it to something and ask if it matches. So step one, we're actually going to create the regular expression. We can do it a couple of ways. One is this. It looks a little strange. We're creating a variable. I'm calling it myRe for my regular expression, equal to /hello /. Now this looks a little odd. Where's the quotes? What do we do? Well, this /, and notice it is /, not backslashes, is marking this as a regular expression. This is a JavaScript shorthand for doing this. There is another way of doing it, which would be this. This is a longer way, but it's doing exactly the same thing. Var myRe equals, and we use the word new, regexp, regular expression, and feed in the string hello into it. What we're actually doing in either of these cases is creating a new regular expression object in JavaScript. JavaScript is what's called an object-oriented language, and I'm using the word new in the second example to actually create a new object. Now, we haven't explicitly done much with objects yet, but we're going to talk more about them later. Now, the word hello is actually as simple a pattern as you can get. What we're going to do is look for the word hello to exist in another string. So once we've created our regular expression, we then have to test it. So let's say I create a new variable called myString, and this is what I'm going to test my regular expression against. So in my if statement, I ask if myRe.test. So .test is a built-in method. Again, it's like a function that belongs to this regular expression. And I'm passing in the variable myString to say, test this, check it. Does it have the word hello in it? And what's going to happen is we get a Boolean response from this. Calling test will return either true or false. In this case, if the word hello exists in myString, which it does, we're going to pop up an alert and say yes. The regular expression objects have other methods that can return different data. More complex patterns are created by using special characters. So to give you a few examples, if I create a new regular expression variable here, and I'm using the shorthand format, which uses the two /, one at the start, one at the end, and whatever's between them is the pattern that we're matching on. The actual / themselves are not part of the pattern. We've seen how to match on the word hello. Well, if I prefix this by this little character, which is the caret character, we're saying that hello has to be at the start. If instead my pattern was hello $ before the /, it would have to be at the end. Using the plus sign inside the pattern means that the L would have to appear once or more. So it would match on these different examples. Hello with one L, with two L's, with multiple L's. HEL*O means that it would be 0 or more. So it would match all the previous ones, but it would also match HEO. The L doesn't have to appear at all. We have the question mark for a 0 or 1 match, which would be a bit more restrictive on what it was matching. Would match HEO or HELO, but would not match more than that. Using the pipe, the vertical bar symbol means we're actually matching either hello or goodbye. The decimal point, just the period, means any character. Using a \W inside the pattern is matching an alphanumeric or an underscore. \B inside the pattern means we're looking for what's called a word boundary, like a space or a new line. You can also use the square brackets to provide a range of characters to match on. In this case, what we're looking for is either C, R, N, L, or D and then the OPE, so it would match on cope and rope and lope and dope. As you're beginning to tell, there's a lot of these, and there's actually way more than I'm showing here. And you can describe extremely complex patterns by stringing them all together. Here's one, for example, that describes a US zip code with an optional 4-digit extension. Now, I'm not going to go through this. Bear in mind, you're going to begin by finding and looking for examples online. If you're looking for regular expressions to match a date or a password or a credit card format, there really is no reason that you should be trying to create it yourself from scratch. This next regular expression here is one that tries to match on an email address. In fact, matching an email address is a pretty complex operation, and people have been debating for many years on what the perfect regular expression for an email address is. Looks very complex, but you can actually see there's kind of repetition of the same kind of thing going on through it. It's really because an email address can follow quite a lot of complex rules. Email addresses are notoriously difficult to match on regular expressions, and this one is certainly not perfect, but it's kind of an example of what you might see and what you might come across. And you'll find this sometimes with more complex patterns, that you're not looking for a perfect match, you're just looking for one that's good enough. And it is worth keeping in mind with regular expressions, particularly if you're brand new to them, that I wouldn't be at all focused on trying to memorize these formats. I'd be more focused on understanding the fact that they do exist, what they can be used for, how they're used. The syntax itself is something you don't need to memorize, not now, if probably ever. They're a tool. They're something to be used when you need them, but you'll find that they're built into most modern programming languages. They're certainly in JavaScript, and they're in almost all of the ones you're likely to come across.